Hey everyone! If you were wondering how we got to this point, go watch the previous video. In that one, we scaffold donation app, wrote the donation jar contract, tested it, deployed to Testnet, and walked the generated hooks and debug UI. This video picks up from that same project. Here is today's goal. We are going to use Scaffold Stacks templates, specifically the SIP-010 Fungible Token template and the SIP-009 NFT template. We will add both beside the donation jar we already have, deploy them to Testnet, then build a simple custom frontend that wires the generated hooks for every important call across the token, the NFT, and a light pass on the tip jar. First template, a fungible token. I type stacksdapp add jar token, template SIP-010. The template already has the standard functions, owner mint, and metadata helpers, and it is safe for Testnet without a broken infiltrate line. jar-token.clar is open. At the top, define fungible token creates the asset. Contract_owner freezes to the deployer. The SIP-010 reads are here. Get name, get symbol, get decimals, get balance, get total supply, get token URI. Public side, set token URI for metadata. Mint so the owner can create supply and transfer to move tokens between principals. That is the whole SIP-010 surface we will wire in the UI. Notice the comment about infiltrate. On Testnet, we leave it out. On mainnet, you add the full mainnet trait path. Second template, an NFT collection. Still at the project root, stacksdapp add jar-nft, template SIP-009. jar-nft.clar. Define non-fungible token with UNIDs. Collection_limit caps the collection at 1,000. Reads, get last token ID, get token URI, get owner. Set base URI for metadata, transfer to change ownership, and mint, which bumps the ID and returns the new token ID. Same story on traits. Find for Testnet as shipped. Add the mainnet NFT trait path before a mainnet deploy. Before we deploy, we validate and regenerate bindings. Stacksdapp check, then stacksdapp generate. That pulls jar token and jar-nft into hooks.ts so the frontend can import them. Hooks.ts now includes useJarToken and useJarNFT families alongside the donation jar hooks from before. Remember the naming. Use plus Pascal case contract plus underscore plus Pascal case function. We will import those into a custom component, not by editing generated files. Deploy time. Donation jar is already on Testnet from the last video. We deploy the new contracts explicitly. Same pattern for the NFT. Stacksdapp deploy, network testnet, contract jar-nft, yes. Let it finish. Deployments.json should now list donation jar, jar token, and jar-nft with full contract IDs. One more generate after deploy keeps bindings and deployments in sync. Open hooks.ts. Jump to the jar token family. Use jar token _mint, transfer, set token URI, and the reads. Get balance, get name, get symbol, get decimals, get total supply, get token URI. Each hook gives you call, data, loading, and for writes a transaction ID that polls until confirmed. Naming rule again. Use Pascal case contract _ Pascal case function. You import these into your components. You never edit this generated file by hand. Further down, the jar-nft hooks. Use jar-nft _mint, transfer, set base URI, get last token ID, get owner, get token URI. Same pattern as the token. Donation jar hooks from the previous video are still here too. The debug panel is useful, but a real app uses your own UI. I am placing Template Studio, a simple custom page that wires every important call across the token, the NFT, and a compact tip jar section. Top of Template Studio. We import CL from Stacks transactions to build clarity arguments, and we import each hook from @generated/hooks. Wallet address comes from the Jotai address atom. Same connect button in the header you already used. Deployments.json tells each panel whether its contract is live. The token panel covers the full SIP-010 surface. Reads refresh name, symbol, decimals, supply, balance, and URI. Mint takes amount in micro units, 6 decimals, so one full token is 1 million, plus a recipient principal. Transfer needs amount, sender, recipient, and an optional memo. The NFT panel covers SIP-009. Get last token ID, get owner, get token URI for reads. Mint sends to a recipient and returns a new ID. Transfer moves a token ID to another principal. Set base URI sets the metadata template. Owner-only Mint matches the template contract we deployed. Donation jar is a lighter panel, tip, withdraw, and the main reads, because we taught that contract in depth already. It is here so one studio page exercises all 3 apps in this workspace. Page.tsx mounts Template Studio on top and keeps debug contracts underneath for double-checking hooks. That is the ship pattern, custom UI for learners, debug still available while you build. Start the frontend against Testnet. I type stacksdapp dev network testnet. When localhost 3000 is ready, we open the browser. Start with jar token. Hit refresh reads. Name, symbol, decimals, supply should appear. As deployer, mint to yourself, try 1 million micro units. Approve in the wallet. Wait for confirm, refresh balance. Move to jar-nft. Mint to your address. First ID should be 1. The lesson is the pattern, templates deployed, hooks generated, custom UI calling every function you care about. That wraps this section. You took live testnet contracts, regenerated hooks, wired a simple custom studio, and ran it with stacksdapp dev on testnet. Pause and replay any step.